All right, so I'm going to jump in. I'm going to go to a new Polypad here. This is called a canvas, is what we at Mathigon call the space in which we use all these tools to make a creation. And all these things on the left are called tiles. So there's geometry tiles, numbers, fractions, and so on. I'm going to spend some time tonight talking about a number of these tiles. I don't have time to go through all of them. Some I will just share quickly. Some I'll go a little bit more in depth. And hopefully you'll see some things that you might want to use in your classroom with students. So the first thing I'm going to start is in the number section. And in the number section, I'm going to start with the number tiles. So I'm going to click on the blue set of 10, and there's a 10 bar on the canvas. I'm going to click another set of 10, and then I'm going to click 4 ones. So I've made the number 24 on my canvas. If I click and drag, I can select both groups of 10 and the 4. I also could, if I click the 10 and I hold down the shift key, I can multi-select the 24. And on a canvas, anytime a tile is selected, at the bottom here will be a number of options that are dependent upon that tile. So with a number tile, I can merge them. So when I click merge, it becomes one set of 24. And there's a black handle here. And as I click and drag the black handle, it makes different rectangular arrays of the number 24. I can spin them and do all sorts of things with them. I'm gonna take this and make a copy of it. Over the course of tonight, I'm gonna be making copies of tiles a lot. And so there's 3 ways that I find myself doing a lot to make copies. One, if a tile is selected, down at the bottom here, there's a copy button. So if I click that, I can make a copy. The other way is when a tile is selected, if I hit C for copy on my keyboard, it makes a copy, and it's just C. It's not Command C or Option C, just C makes a copy. And the other thing that you can do, if you hold down the Alt key, ALT, and just drag, it makes a copy. All right, so there is 1 by 24. I could show 2 by 24. I'll drag it over and say, sorry, 2 by 12, right now 2 by 24. There are 3 groups of 8. And 4 groups of 6. In the background, there are a number of options for the grid settings. I'm going to turn on a grid setting here so I can show a little bit nicer for my students what these numbers are. 2 groups of 12 and 3 groups of 8. And then we certainly know 5 is not going to work, right? But I'm going to spin this around here, whoop, right? And so 5 is not going to work. And what I might do here is I'm going to split the tiles. So down here at the bottom, I've merged them. Now I'm going to split them. And I might show them that those 4 tiles at the bottom show us there's 4 left over, right? So 5 times 4 is 20 plus the 4 left over. And so I can continue to use these number tiles to show factor pairs of numbers, right? And in 6th grade, when we talk about factors and multiples and primes and composite, this was a great introduction to that conversation. Here is a 10 by 10 block. I'm going to split it. I'm going to highlight 9 and delete. There's a delete option at the bottom. I can hit delete on my keyboard. I'll re-merge them together, and there's a group of 91. So I could show that when it's split into 10, there's remainder 1, 11's remainder 3. I could stop here and split them again and make those a different color, right? Let me take all of these and copy them. And we know for many students that initially 91 might feel prime, but as we go to 13 times 7, shows that 91 is a composite number, right? So all sorts of wonderful things to do with these number tiles. I'm going to go make a clean canvas here. So I'm going to go to library and make a new Polypad. I don't need to save these changes, so I'm going to discard it. A theme that I'm going to be talking about tonight is how we can help students use these tools for when they're still thinking concretely about an idea and as they're moving along to the abstraction of the idea. So a number of examples that I've done in class is questions like the following, right? Show all the factor pairs of 36. And so I might ask this question for them on a canvas. And here I would give them 36. So there's 30, 2, 3, 4, 5, 6. I'm going to merge them all. And there is 36 for them. But then I ask questions like, right, what is the remainder when 40 is divided by, right? And then I might say, use number tiles as needed, right? So in this first question, I want them to use the number tiles to show all the factor pairs. But here, it's up to them. If they have abstracted this idea, great. So what's the remainder when 40 is divided by 3? I can make this bigger. I can change the color of the text. I'm going to copy this now. Let's do, I don't know, 3. I'll change this to 5. And I'll do one more and make 7. And here's what I am so excited about as a teacher is this question builder down here. So now I've made some questions for students. I'm going to drag a text box onto the canvas. And I'm in a teacher account. So I have a Mathigon teacher account. If you don't have an account, when you sign up, you can choose whether it's a student account or a teacher account. So as a teacher account, there is the question builder feature. So I know that what's the remainder when 40 is divided by 3, 1, right? And remainder 0. And what's that? Remainder 5. So now I'm ready for my students to engage in this activity. I'm going to go to my library and save it. And I'm just going to call this factors and remainders, right? So I'm going to call this factors and remainders, save it. And now I want to share this with my students so they can work on this Polypad. A number of options here. There's a share and embed option on the menu on the right. And here you could get the link and post it in Canvas, in Google Classroom, on a Google Doc, however you share links with students. You could post it directly to Google Classroom on the Google Classroom School. And so that pulls up the menu in Google Classroom. But what I want to show you tonight is how to assign it to a class in Mathigon. So I'm going to go to my teacher dashboard. I'm up in the right here, top right, teacher dashboard. And I'm going to make a new class for tonight. So I'll call it Mathigon example class. You see, I've made this already, and then I deleted it. So I'm going to make this class, and no students have joined yet because I just made the class. If as a teacher, I sync it with Google Classroom and I click import from Google Classroom, and my students automatically show up in my class. But for tonight, I'm going to show you how students can join with the code. So I'm going to copy the code, and I'm going to go to a different browser window. And of course, my daughter has a Mathigon account. So I'm going to go into her Mathigon account and go to the student dashboard. And so in student dashboard, she's going to add a new class code. So I'm going to copy in the code that I just paste in the code. And there she is. Her teacher and parent actually is me, David Poras, right? So there I am. She's in my class. If I go back on my teacher page and do refresh, there she is. She's done some work on angles and polygons already. Good job, Emily. But here's what's very exciting. Now I'm in my teacher Polypad. This is the one that, I need to go back to Polypad here at the top. And factors and remainders, I saved it. So there it is, all ready to go. And I'm going to go to class here. And there's a default class. That's the one that started. But I just made Mathigon example class. So I'm going to choose that class. And I'm going to assign this canvas to her class. So I do assign, I've shared it, great. Now as a student, I'm now back in my daughter's account. She goes to Polypad, and under her library, right? So here were the tiles where you can pull things, but under library, there is her assignment. That's what I just assigned to the class. So she would click on it and she would get to work. So maybe she would do 2 and 18, and then she might copy it. I would have obviously spent time in class doing this. So she would be making all these factor pairs, right? And then here, maybe she knows what the remainder of 40 is when it's divided by 3, and she thinks it's remainder 2. Oh, wait, it's not remainder 2. Maybe she thinks it's remainder 3. Oh, it's not. And then she might say to herself, I should use these number tiles to help me. So she can go to tiles here and go to numbers and build a block of 40. There's 40. And what I love about this, I've used a lot of manipulatives in my years as a teacher, right? We have them in class, we use them for a day or two, and then we hope that kids have abstracted the idea. And some of them have, and I tell kids all the time, the manipulatives are on the shelf over there. Anytime you want them, go grab them. You can use them for homeworks, quiz. They can bring them home if they want. They can use them in class, right? And on tests and quizzes. And really what happens is the kids that really need them often don't get them, despite my hard work to create a safe safe environment where all tools are welcomed and we all learn at different times. Kids still, sometimes when they see their classmates not using the manipulatives in middle school, at least they don't want to go grab them. So here, she's doing this at home or in class on a device, and she can build 40 and use it as needed, right? Without that sense of, oh, I'm not sure if I should be using it or not. And there I made groups of 3. Oh, and there's 1 left over, right? And let me try to make groups of 5. Yeah, there's no remainder with a group of 5. Awesome. And 7, right? It's remainder 5. Oh, and now that she had the tool to use, she got them all right, and confetti rings down on the screen, right? I've had students who don't finish, and I'm like, you don't need to finish, it's all set. And they're like, no, I want the confetti, right? Which is wonderful. So they keep engaging with the math to get the confetti. So now she's done. Great job, Emily. She would save it. So now as a teacher, I go and I hit this little arrow to reload, and there's her work. So as a teacher now, I can see her factor pairs, she didn't quite finish. And here I can see that was her 40, right? She built 40. So that's giving me great feedback as a teacher that she chose to use that tool, right? That she found it helpful to use the number tiles to think about the factors of 40. I could turn off her name. So if I wanted to share this with the class, I can toggle back and forth to her name. I can see underneath it, it's green and orange. That orange means that on one question, she got it right eventually, but needed a couple attempts to get it right. There is a spreadsheet I could download. If there were lots of students here, it would tell me on the spreadsheet how many they got right on the first attempt, how many they got correct after multiple attempts, and how many they got incorrect. So I think I'm going to be talking about this a lot tonight, the ability to create a space where kids can use manipulatives if they need to. If they're still thinking about things concretely, they can. And if they don't need to, that's great too. They've abstracted the ideas, right? So I'm really excited about that opportunity as a teacher. So then actually as a teacher, I can go to my class and unassign that canvas. And then I just want to show you on her page, when I do a reload, it's gone in her assignments. It's a saved Polypad of hers, right? But it's no longer showing up as a teacher assignment. So that keeps her assignment page neat and free from Polypads that are no longer assignments for hers. All right, that was a good dive into how teachers can make assignments and share them with students. Let me make a new canvas here. I don't need to save that. And I'm still in the number category. There's number bars. These are the Cuisenaire rods. I just want to show you under settings here, you could change the colors to the more traditional Cuisenaire rod colors. And I can hide the number labels. When I toggle back and forth on the number labels, they appear or not. So that's true for a number of the tiles. There's a number line. I'm not going to spend a lot of time on the number line, but I want to show you, you can zoom in, you can make it extend in each direction. You can make it a vertical number line, right, in whichever direction you want. You can change the starting number up here of the number line. Right, I could start at 5. I could count by 2s. I can change the width on the screen between the numbers and make them 5 apart. I could change the number of divisions between the whole numbers. Let's put 2 divisions in between each, and 3 and 5 and so on. So all sorts of great features with the number line. There's number cards. I'm going to come back to the prime factor circles. Number cards are just a card with a number. These could be good for an open middle question if you want kids to move numbers around the screen. When you put 2 numbers on top of each other, it's the sum of those numbers. You can enter in any number you want, including a negative number, right? We'll get to some algebra tiles much later on. There's a multiplication grid, which I think is great. There's some nice features of this multiplication grid where it starts where this orange square is a 10 by 10, and as you drag it down, the multiplication grid expands. But what I think is really exciting is you can change the base in which you're multiplying. So again, it started as a 10 by 10, but as I take this dot and drag it, this square is changing. So now I'm multiplying in base 5, right? This is a 5 by 5 square. There's a 25. There's a 5. There's a 1. If I go up to base 7, there's a 49 and a 7 and a 1. And that's pretty fun. And then there's exploding dots. This is a preview mode. It works, but we're going to be adding a lot more features to exploding dots as we go. But I want to show you the prime factor circles. So if you've played Prime Climb made by Dan Finkel, or you've seen the grid of the prime factors of numbers, this might look familiar to you. And so the way it works, I took 18 and put it on the canvas, and I can pull these apart. I'm going to pull apart the 3 here, and then I can pull apart the other 3. And there's the prime factorization of 18, 2 times 3 times 3. You can put it back together and get 9. And I think that ability for kids to pull apart the factors, the prime factors of a number, to see that that's what it takes to build the numbers, is really a powerful visual for what prime factors are. Right? I can build any number down here. Here's 100. We know that that's 2 times 2 times 5 times 5. It also, you could do a whole exploration on square numbers, right? This makes a square number because I can split them into 2 groups of the same factors, is really exciting. You may know that 2021 is a prime number. And in fact, it's the product of 2 primes that are next to each other. 43 times 47. So we talked about this in January. And of course, kids want to know, when's the last time it happened? So I put on 41, and I was like, do you think I was alive then? And they were like, I think so. And then we showed that, and they were like, yeah, you were. And they thought that was funny. It was fine. And then we said, when's the next one? And of course, kids first said 49 really quickly. So I dragged out 49, and they're like, oh yeah, no, that's 7 times 7. And then of course, kids thought 51. Even though we've done divisibility tests, right? They very quickly said 51 and said, oh no, that's 3 times 17. And then 53 is the next prime number, right? So the next time this happens is 2491. So that was a nice way to show that pattern of prime factors of 2021. I have used these a lot with kids in thinking about factor pairs of numbers and greatest common factor and least common multiple. So I just want to show some quick examples of this. So I'm going to take the number 18, and I'm going to copy and put it over there, and I'm going to build factor pairs of 18. Of course, I could do it with the number tile. So there's 20. Let me get rid of, oops, let me split this. Oh, I did already, but I just want to get rid of 2 of them. So here is the number tile for 18, and we could certainly do the factor pairs for that. But then we use the prime factor circles and said, all right, I could pull out a 2. So there's 2 times 9. How else could I pull out one factor? Well, we could pull out a 3, 3 times 6. No other ways to pull out one factor. So then I had students go over here, right? They were doing this with me. And we said, what about 2? Can we pull out 2 factors? And they said 2 factors would be a 6. And of course, kids were already chomping at the bit to be like, we already have that one. But I didn't let them do it. Well, I wanted to keep going. And so there's the 2 and the 9. And then I said, what would go over here? Here we pulled out 1. Here we pulled out 2. How many would we pull out here? And they said 3. And I pulled out 3, even though it felt kind of silly. I copied that by mistake. That's why there was 1 left, right? Let me show that again. I could pull out 3. 1, 2, 3. And then great conversation about what should go here. And of course, kids were quick to say 0, there's nothing. But we know 18 times 0 is an 18. So in the prime factor circles, there's a 1. So we put the 1 out here. And then we talked about, what if you don't choose any? Right here, we were choosing 1, choose 2, choose 3. What if you don't choose any? Well, that should be a 1. And of course, kids wanted to say all there were pairs here, right? So we talked about how this could be a model of 2 times 9. And if we spin this around, that might be 9 times 2, right? So both in the number tiles and in these in the prime factor circles, the factors come in pairs. Really exciting. And then we talked about how we can use the prime factorization to build all the factors, right? So I was just doing prime factor pairs. I want this to be 18. Let me just do this, right? So now, then, I mean, of course, I gave them like lots of time to practice this. I made questions in a Polypad with the question builder. So I could see if they were pulling numbers apart or if they could just visualize all the factors, right? And that was really good feedback for me as to which kids were still really concrete and pulling it apart was helpful, and which kids were able to abstract those ideas, right? So then we talked about building all the factors here. And so we could say, all right, let's start with 1. And we know that so now there's a pen tool. I haven't talked about the pen tool. There's just a draw tool. There's a thicker line you can draw. There's a highlighter that you can draw with. And then there's a ruler to draw a straight line. So I'm going to draw some straight lines. You can change the color. I'm getting so into the math, I'm not highlighting all the tools for us. But I want to show you just these trees that I made with kids to say, all right, oh, I just did two of them here. There's an eraser tool, right? So I'm going to go to the eraser tool and do that. And when I'm choosing a two, right, we could either choose the two or not choose the two. And so there's the factor of 1 and the factor of 2. And then we talked about, what about for the threes? If I'm going to the pile of threes, what choices do I have? And we talked about how you could have a 3, you could have 1 3, right? You could not choose a 3 at all, or you could choose 2 3s. I'm much slower in class with this and have them do a bunch on their own. Let me get this out of the way, right? And this was in 6th grade, so we never really did the formal discussion about you take the exponents of the prime factors and add 1 and multiply it, and that's the number of like factors that you make. But kids were building these ideas, right? Because they saw that this would go over here, and this would go over here, and these two would go over here. I lost one, there we go. And that there's 6 different factors, right? Because each one of these going down the line makes a factor. This line, when I go down, there's a 1, and then there's a 2, and then there's a 3. So there's a factor of 6, which I think is that ability to pull these numbers apart and think about how they're going together, I think is building such really amazing connections for students as they think about prime factors. Let me just share an example of a factor tree for 180 that I had some students work on. I let them choose a number and had them make a factor tree like that, right? And that was like enjoyable for them. There's something very satisfying about pulling them apart and putting them together. So that's kind of fun. All right, that is numbers. I'm going to go into geometry here. Of course, there's so many wonderful things in geometry to talk about. There is a link to the links that I'm going to share in the next section. If you go to mathigon.org/PD/310, it brings you to this page. You don't need to go there now, but I just want to show you that I'm going to begin to share a bunch of these. So the first activity that I did with students, I assigned to the class. This was in area and perimeter. And so I'm going to assign it to my daughter's class. I'm going to assign it to her and then go to her account and reload it. And there's the assignment, right? So this is using Pentominoes. And so this was an activity I had kids in breakout rooms. Actually, this was back in the fall when kids were at home. My students are back in person now, hybrid. And so they did this in breakout rooms. They were able to talk to each other, and they saw this is made up of 2 non-overlapping pentominoes. Here was the outline of the shape, and I asked them for the area and the perimeter. So they could get 10 and 14, and confetti comes down. But then the real exploration was asking them to make shapes that use 2 of them, right? So I'm gonna take one of these and drag it down, and then maybe take this one and go like that. And then students would find the area and perimeter of that shape and put it in their Polypad. They could use the text tool and put in the area. I'm not going to spend time on it because there's so much more stuff to talk about. But kids did this in breakout rooms. They saved it, right? And then as a teacher, I did a refresh, and then I could see what students had done, and then I could share this canvas with the class as a whole class discussion. So that was a great introduction to area and perimeter. They got excited trying to build ones with the biggest perimeter and the smallest perimeter, all sorts of fun things. And then we got into talking about area and perimeter of rectangles and parallelograms and triangles. So I shared with them this Polypad. And again, these are the tiles here. I'm going to talk in a minute about how to make these tiles and how to get them on the screen with the polygon feature. So I just showed you one that was using Pentominoes. So here are the Pentominoes. There are Tetrominoes as well. I'm going to dive into the polygons in a second. I just want to share with you an example that I did in class. So again, in pairs, students found the area of these shapes. They could take the rectangle and rotate the rectangle. And that was just a reminder for them. But then it came to the area of a parallelogram. And so a new feature we've just added to Mathigon, which is really exciting, is the cut feature. So students took this parallelogram. When you click on it, here are the menus that come up. I'm going to cut it. And so students were inclined to cut it right here and then move that triangle over there, right? I've done this for years in class, but I've drawn it on the board and I've erased the triangle, moved it over. We've done it on paper and cut it up. Lots of good ways to get at this idea. I found this a really engaging, powerful way for kids. They could change the color and make it like that. I'm going to undo a little bit because there were also students that when they clicked on the parallelogram, they saw, oh, this was a 2x4 triangle and this was 2x4. So they saw those are the same. So they thought to move this point over and move that point over. And there's the same rectangle, which is really funny. So in this parallelogram, we could do the same thing, right? We could cut it right down the middle, right? Cut it down here. Whoop. So I think it's not on the grid lines. Let me undo that and just move it over so it's on the grid lines. There we go. And now we could cut it and go from there and move this one over here, right? And then we do the same with this one. And then some triangles came up. And I just want to share some, which was great in class. There were students that took this triangle and they cut it right down the middle. I think I missed a little bit. No, that's good. And they took this and they copied it. I'm going to go to copy and they spun it around, right? And they changed color. Maybe make it purple and put it in place. Then they did the same over here, copied it, spun it around, and changed the color, right? Great. That was not very surprising. But then what was really cool is, of course, there were students that said, well, they just took this triangle and they copied it and flipped it and made a parallelogram, right? And this, if students had been doing this on paper, or I was doing it on the board, it would be hard to show this at the same time. So when this was projected and kids are describing it, now they said, let's take this and cut it. So now they cut it right here and they said, let's take this and move it over. And it was the same shape. Right? It was really satisfying for students to see that both of those ways to think about it got to the same place at the end. Here, took this and made a copy of it, but it was also fun to talk about how there were a number of students that wanted to cut it right here. And they did, of course, go for it. And then they had trouble thinking about what they could do with this. They tried putting it over here, and then they took this and they cut it up and they made a whole mess of the shape, a great mathematical mess. And they tried to get it into a rectangle, and that led to awesome conversations about what shapes are we making here? And, if this wasn't on a grid, what would be the pros and cons of this process? And then I'm not going to assign this to my daughter's class. I know I'm going fast here, but there's so much awesome stuff to share. Hopefully you're able to follow some of it and take away some good ideas. Then I assigned this canvas to the class. Here are the answers, right? So I assigned it. The answers on their canvas didn't show up. But what was awesome, again, as a teacher, I could see the students that took this parallelogram and cut it and moved it over here. And I could see the students that could look at that parallelogram and envision that going over, right? And again, what awesome feedback about where students are on that spectrum from concrete to abstract. We talked about it in class after, and there were students that said, I knew that would be 50, but it was really fun to cut it and move it over, right? Which I think is so powerful that the tool incentivized them to cut it up and move the pieces around. And again, those connections that are being built, I think are really powerful for kids. Right, so that was really exciting. Let me go to a new Polypad, and I just want to show you the tiles here. So there's all these polygons, right? I can take a square and put it on the canvas. I can take a triangle and put it on the canvas. I'm going to move these over. They snap together. Let me zoom in a little bit. Right, so it's like an automatic snap together. I'm going to copy this and rotate it. There's all sorts of snapping when you do it, and smart rotation. And so let me do one more, and you might see where I'm going with this. I'm going to try to complete this. Oh, I unclicked it, right? And I did this with students, and then we put the hexagon in here, and then we were off and running to Tessellation City, right? So let me select a bunch of these. There we go. I'm holding down the wrong key. Shift key is the multi-select, right? So I'm holding down the shift key, and now I touch the C key to copy it. I'll click C again. I can highlight this whole thing and rotate it. And the reason I want to rotate it is so I can just grab the top half, and now I'm off and running, and I can tessellate this. And so, students have so much fun with this, all sorts of great conversations. what's the one piece that tessellates, what's the ratio in that piece of the squares to the triangles to the hexagons, and so on. So amazing things that can be done with tessellations. I'm going to pause here for a second and show you that down here under library are examples of pre-made polypads. So here's an example of a tessellation that you can explore with students. There's also a link down here to all the accessibility features that I've been talking about, the C and the Alt key. And there's links to a number of lesson plans that are some ideas of how you could use Polypad in class with your students. One more thing to show you in the geometry tools is just this shape. So all of these polygons are fixed, meaning you can't change the size. You can rotate them, you can move them around, but their size is fixed, except for this one, this green one, which is a custom polygon. So this starts as a pentagon. I can drag the points around. And so there's my pentagon, but if I click on a side length, it makes another point. So I click anywhere on the side length and I'm adding points to that shape. If I want to get rid of a point, you can click on the vertex and it goes away. Right, so I'm going to get to a quadrilateral here. Oh, I've made a funky one. All right, so there's my quadrilateral. Now, if that's a shape that I'm very happy with, and I don't want to move the points around by mistake, there's a lock feature down here. So all those rectangles and parallelograms and triangles that I made for my students to cut up, I used this feature, and I had on a grid background because when you move it around, it snaps to the grid. So I could make a rectangle like that and then put it on the canvas, and a parallelogram and a triangle, right? So, but I want to take this one and I'm just going to take it. I'm going to lock it so I don't mess it up. I'm going to copy it. Let me change the color, flip it around, and you may know that any quadrilateral like this you can use to make a shape that tessellates, right? So let me zoom out a little bit. And now this, my students have had so much fun with. They just do this when they're like, have nothing else to do and they want to go make some math art, right? They take this and they drag it up, and then they get really excited at a moment like this where they take the copy and they're like, is it going to fit in? Is it going to fit in? Of course it fits in, right? It's really exciting. And then so I could keep going with this, change colors, all sorts of patterns, right? Wonderful, wonderful explorations and fun can be had with making shapes like that. I'm going to fly through the rest of the geometry tools and then jump to the probability tools. So there's tangrams. There's a whole link to some tangram puzzles. There's the magic egg, which you can learn a lot more about and do some fun things with. I showed you the pentominoes and tetrominoes. There's a ruler and a protractor, so we could measure the length of that. If I wanted to put the protractor tool out and measure these angles, we certainly could. You can spin this around, and it snaps to the points, right? So you can see as I was getting closer here, it snapped to that point. There's Penrose tiles, column tiles. You can build your own fractal. A tweet just came out about that today from the Mathigon account. Please follow at mathigon.org. At mathigon.org is the Twitter handle. All sorts of great ideas. And there's Tantrix tiles. But I'm going to jump to the probability tools. I know there's questions in the chat. I don't have it up on my screen, so I have a few more things to show you, and then I can stay on and answer any questions that people have. So I'm going to show you quick probability things, then some algebra tiles, probably about 10 more minutes till 7:45-ish, and then I will open it up to questions. All right. So the probability tools I love. I mean, I love all of these. They're amazing to work with. Here's the dice that I can spin. Right, so the dice spins around. Here's a coin you can flip. Make this a little bit bigger. There's two kinds of spinners, a uniform spinner and a custom spinner. So on the uniform spinner, all the regions are the same size, but this circle changes the numbers of regions. So I could pull out the protractor that I just showed you, and we could have students explore all sorts of fun things with that. In the custom spinner, you can change the sizes of the regions. If I click on a point, I get rid of a region. And if I click on the outside of the circle somewhere, you can add a region. So you can make any sort of spinner that you want. Is really exciting. What I think is so powerful about these probability tools is the ability to do lots of trials of something really quickly. So I'm going to put some dice on the screen, and I'm going to make 100 pairs of 2 dice really quickly. 3, 4, 5. Probably got to zoom out a little bit. So there's a set of 5. I'll just drag these over. Of course, if I was actually doing this in class, I would have it like pre-made for students and just share, but I just want to show you how quickly, in a matter of maybe 30 seconds, I can get 100 pairs of 2 dice on the screen. I think that's 5 times 10. It is 738 after a full day of teaching. So there's probably a 15% chance that's 90 or something, but I think it looks okay. All right, there we go. So I can zoom out a little bit more, and within a matter of seconds, right? And again, if I were doing this in class, I would have pre-made this and shared it through Google Classroom or something. But then I can highlight all of these and randomize, rolls them all at once, right? And just, the zoom is kind of slowing it down a little bit, but there we go, right? How cool is that? And then as a class, we could say, all right, everybody do it and count how many 4s came up, right? And if there are 100 here on the screen and I got 25 kids in class doing it, all of a sudden we have 2,500 trials of rolling 2 dice. Now I know there's lots of like dice simulations out there where you say roll it 1,000 times and you see the bar fill up of how many of each number that came up in the background. I always think students don't really believe that because they can't see what's happening. Here, each kid in 3 seconds can roll 100 dice, and on the board you could record all the 4s, and I think that's believable for kids. And then you can compare that to what you would expect in 2,500 rolls, and what did we actually get? And I think there's lots of data sets that can be really powerful, right? Maybe we can say every time a 7 comes up, we're gonna take the 7 and remove the 7 from the 100. I'm not gonna go through and do it, right? But kids could roll it and the first one to get all their dice gone is the winner, or the first one to have 50 dice left, right? And like exponential decay just through this game of trying to get rid of the 7s could be a really fun activity. When I do probability in 7th grade, we talk about the story of Chevalier de Mere. So this link is in the links. That's at mathigon.org/pd/310. The story of probability with, I don't need that new tab. If you're not familiar with the story, where did it go? All right, too many tabs. Here we go. I'm back. It's a wonderful story in the history of probability. It involves Fermat and Pascal. Go check it out. Google it. It's awesome to do with kids. And the first game that he thought of was how many there was a game where you're trying to roll at least 1 6 and 4 rolls of a dice. And you win if at least 1 6 comes up. I'm a winner, I got 1. And then I got 1 again, right? And so lots of trials here. I would do this in class. Kids would have 4 dice. They'd play against each other. It was great, but we wouldn't get a lot of data. We'd get some, but now a kid on their own, there's 24 trials of this, right? And you could count how many times at least 1 6 came up. So there's all sorts of wonderful math there. And then his second game, again, great story, go read it, is rolling 24 pairs of dice and trying to get at least 1 double 6. This was always hard to simulate in class. I would give each kid a pair of dice and they would roll it, but we'd have to get 24, and the chances that I had exactly 24 kids in the class, not very good, right? So some kids would get to go twice or not, and we'd lose track of it. Here, every kid has 24 dice and they roll them. And how many pair of 6s came up? I got it, I'm a winner, right? And then we roll it again. So the ability to do lots of trials, I think, is really powerful here. I did a very simple probability tree, right? I made this and I could share it with my students. Very typical middle school probability question, right? What's the probability of flipping heads and rolling an even number? Let me see if I can get a heads and an even number. I did not. And then we make the probability tree. Again, I would have students do this. I just wanted to share an example. And we'd say there's 3 out of 12 ways. So the probability is 1/4. And then we ask kids all sorts of questions, right? If you do this 40 times, what would you expect? And the answer is 10, right? But now let's actually do it 40 times, right? And I'm not going to go through and count, but did I get 10? I don't know. And if there's 20 kids in class doing it 40 times, right? There's 800 examples, and you could have kids list on the board how many out of 40 they got. 9 out of 40, 11 out of 40, 13 out of 40, right? And see that as you average those, it's getting closer and closer to 10 out of 40. So I think that is really, really powerful. The last thing is the algebra section. There's fractions, which I'm not going to dive into tonight. There's the typical fraction bars, all sorts of wonderful things with fraction bars and fraction circles, but I want to show you some of the algebra tools. So I'm going to go to a new canvas, and let me show you the algebra tools. There is algebra tiles, I'll talk about in a second. There's a coordinate grid, which is new just the past week. This came out, I think. So you can change all the numbers just like on the number lines. But I want to show you the scale very quickly. This is also in preview mode, which means like there's some features there, but a lot more coming down the road. So in the scale, when you put on any of these objects on the scale, it starts with a value of 1. Right? So right now the scale's balanced. I put a 1 on here, and it's not balanced anymore. I'm going to go to the numbers. I think also what's great about this virtual, the tools here is you can use them all at once. I've been showing you bits and pieces here. I'm going to end with some examples where they all come together. Here's an example where it all comes together. I'm going to go to the number cards, and let's put 6 over here, and maybe 40 over here, right? And so it's not balanced because, as I told you, the Polypad assigns this a value of 1. But if I click on the scale, there's a balance button down here, and that makes it balanced now. So now this weight has been assigned the value to make this balanced. We know it's 34, obviously. But then students could explore how to figure out what that is. Again, most middle schoolers could take a look at this and know that it's 34, but maybe 4th and 5th graders, this could be a good activity, and you could certainly enhance this and make it a little more challenging. But what I want to show you, which is kind of cool, is there's these negative number cards. So maybe a student's like, I just want to put on a -6 here. Oh, wait, that didn't keep it balanced. Let me do a 6 and a -6. All right, let's see. Obviously, that's not going to keep it balanced, right? But when we put on a -6 and a -6, right, that's going to keep it balanced. And then we can put those together to make a 0. I like that the 0 stays there because now I actually have to get rid of it. And then we can put those together to make 34, which I think is a nice feature here. And then I'm going to end, I know at 7:44, I'm going to go a few more minutes, then I'll take questions. There are the algebra tiles. A lot of amazing activities out there in the math world on the use of algebra tiles. So here, the 1 and the -1 make a 0 pair, right? That's what we're used to with algebra tiles. The x and the -x make a 0 pair. There's a negate button down here, so you can turn them on and off, or positive and negative. And then there's the x squared and the -x squared. There's the multiplication grid, so you can do all sorts of factoring and distributive property and all sorts of wonderful things in Polypad here. I've been doing adding positive and negative numbers, and so we did a lot of work with these tiles to help students make sense of things. And then I just want to share you again another example of finding out for me whether kids have abstracted these ideas or not. So here's a canvas. This was actually a version of a canvas that I shared in a webinar with teachers, and then I got an email from a teacher that this was her version that looked much nicer than the version that I had made. This is the teacher version, right? So I could assign it to the classes. I also just want to show you if I copy this link and go to a new browser that I am not in my teacher Mathigon account on. I'm in my daughter's account, but it's going to bring up that Polypad with the question marks there, right? So you don't even have to be in a student account. You can just take this link and share it with anybody. Now, their progress isn't going to be saved if they're not a student in your class, right? But here, maybe my daughter knows that that's 5, right? And doesn't need the tiles here to help her. But maybe here, when it's 12 plus -15, maybe that's beyond her ability to abstract. So she takes the 12 and grabs a 12 and brings it over. And then she takes a -15 and brings it over, and then puts the 12 on top, and there's -3 left, right? And so again, it's providing students the tools to use the manipulatives as they need. I use algebra tiles, the actual chips in school all the time. I'm sure many of you do as well. It's an awesome teaching technique, right? But again, when kids need the chips, they often don't go grab them a couple days later, right? Even though they haven't made those connections yet. And so giving them an environment in which they can do this, I think is really, really powerful. The last thing to show you about algebra tiles is this activity that I made on factoring quadratics. And this is just an example of putting the probability tools with the algebra tiles. So here, the activity would be to roll the dice and spin the spinner to make a quadratic equation, and then see if you can factor it. So I got x squared. I said the heads was positive. So I got x squared plus 3x. So there's my 3x. And what's on the spinner? -4, right? So then I would see if I could factor that. I'm not going to go through and do it because I've been talking too much. But again, then what students could do is they could keep track of their results, right? How many of the ones that they spun were able to be factored? How many were not? What's the probability, right? I don't know what the probability is that this is going to be factored. That's something I've been thinking about, but I don't have an answer to that yet, right? And then I thought about maybe you could say if it's not factored, maybe you can switch the sign of one of the numbers, right? That's changing the equation, so I don't necessarily love that kids might think you can always just change signs, but you could have some fun with that. So those are the algebra tiles. Again, I didn't get into the fractions, but there's all sorts of fraction workspaces that I've made with students. There are some games here. I'll just show you a Polypad version of the Genius Square. It's an awesome board game. You know, there's a link down there. In the Genius Square, you spin all these. And this is just kind of fun to see, right? So you spin all of the spinners, there they go. These squares you put in the spots where they came up. I'll say that's C4. I might spin it again, actually, because it's right in the middle, right? So that was C3, so I put this in C3. I put one in D6. I'm going to stop there, but you keep putting in those, and those are like the blocked out spaces, and then you have to use all of these shapes to fill in the ones that aren't blocked off, right? And all possibilities are possible. You can buy the version of the game down here, but this is a nice visual of the game. All right, that was rapid fire. I see we have some Q&A and some things in the chat. I can pull that up and I can take a look. I have most of the questions. It looks like Philip has been answering the questions in the chat, so that's great. There was a question here about percentages. There aren't any number percentages thing, you know, there aren't any percentage tiles, but certainly, you know, off the cuff here, I could make on the grid here, I could use the drawing tool to make a 10 by 10 grid, 3, 4, 5, 6, 7, 8, 9, 10, and go over 10. Maybe that was 10. Oh, there we go. And then ask all sorts of questions about, you know, what shapes could you do to show 37.5%, or, you know, all sorts of questions with the percent. There's a question here, do students work on the same Polypad? So there's not yet the feature for multiple people to work on a live Polypad. It's not quite yet like a Google Doc where students can see what other students are doing. We've certainly got a lot of questions about that, and hopefully at some point down the road, because that would be a nice feature. So what I've been doing in breakout rooms, you know, that example with the triangles and the parallelograms, I had students doing it in the breakout rooms, talking to each other. I allowed them to share their screen so they could show to the other students in the breakout room, you know, what they had been doing. It's pretty fun. Are the pre-made activities available? There are some, right? So down here under lesson plans, there are, you know, there are some here that are in the on the website. One of our big things that we are working on behind the scenes is a number of to increase the number of tasks that are available, you know, for teachers to use. We have been putting a lot of stuff out on Twitter. So at Mathigon.org on Twitter, I'm at David Poras. Both of those are good accounts to follow for Mathigon activities. Oh, can I share? I'm obviously we're gonna stop at 8 o'clock, but I forgot to share one of my favorite things that I'm gonna take this liberty to share. It's a visual pattern. So I meant to do this in the geometry section, and then I didn't. I want to share with you what I've been doing with visual patterns, because I know a lot of you out there love visual patterns. What an awesome teaching tool. Here's an example of a canvas that I would share with my students. You know, what I like about this canvas is, you know, when students are building their figures and they think they have a rule and they want to know the number in figure 43, on visualpattern.org, it gives them the number, which is nice. I often hold back on the number to not kind of give it away. But here, if a student was doing this, right, they would see all those blanks there, right? So a student would explore the pattern. It's coming out, no, it's not. They would build the figures with their tiles, and they would put in numbers here, like to see if they got it right. So this visual pattern in class, you know, I made this answer key to have a conversation in class. And I just want to share with you a few things that happened that were really I think, showed me the value of having this on the screen when students were talking about it. So of course, in this visual pattern, there were students that said, in figure 4, I saw a 4x6 rectangle. So as they said that, I made it like red. And then they were like, and I saw the 2 on top. Great, so that was 4x6 plus 2. We found the algebraic expression for that. Great. Then there were kids that said, oh, that's cool, but I saw a 4x4 square and then this 4x2 rectangle. Awesome. And typically in class, I'd be doing this on the board. I'd be making a mess of the picture. I'd be using too many colors. I'd try to erase it, but I'd lose the figure. Kids couldn't really follow what other kids were doing. They would have it. I'm lucky enough to have whiteboards all around my room. So kids might share it, but it was hard to make sense of it because the pictures get messy. So here, when I was doing that as a kid, was talking really clear. And then of course, there was a kid that said, oh, that's nice, but I made a rectangle. Let me use the ruler tool to make it straight. Right, so they built a rectangle here, awesome. And then they talked about the squares here that would be filled in, right? So these squares here, we'd have ones we'd have to subtract. So I brought some over and made them in a different color. And then for all of these, we found the algebraic rule. All the same, simplified algebraically, great. But then there was a girl that was like, oh, I saw it differently. And so what she said, she was like, Mr. Poras, can you take that long one and just kind of pretend it's not there? And I was like, what? She's like, yeah, just pretend it's not there. And I was like, I can do better. I can like move it out of the way. And this is something I hadn't planned on, right? So I have an idea of how these visual patterns are going to go. And sometimes I could have pre-made things ready for them. But this one I hadn't seen before. She said, just kind of move it out of the way. I said, great. And then she said, see that one by itself, just kind of pretend to move it over. And again, I was like, I don't have to pretend. So I did that. And then she said, now that one that's by itself, if you kind of spin it over and move it up. And I was like, yep, I can do that. So I spun it over and moved it up. And then she was like, yeah, and then I saw a square. And so that figure 6 was 7 by 7 plus 1. And that was such an awesome like moment for her and for her classmates to see. That might have been one if I didn't have these tools ready to go, that as she was describing it, because she also had trouble describing it. I wasn't quite following it at the beginning, that her classmates might not have seen what she was describing. And being able to do it on a Polypad really easy like that, it gave her the like wow moment from her classmates. Her classmates were like, that is awesome. That's so cool, right? So that was a really like good moment for her. And I think the tool like, enabled her to have that moment, which was really exciting. Visual pattern 19 is right here. So it's under geometry in visual pattern. And then what I did as a teacher, right, I made a different Polypad where I had figure 4, 5, and 6 filled in. So then we could talk about it as a class. Yeah, it was so cool. It was a really like happy teacher moment. Awesome. I think those might have been all the questions. I'm happy to answer any more questions that people have. March 24th, there's another webinar for elementary school teachers. So it'll be similar to this, but if you want to come again to take it in and hear more about how you could use it with, K to 5, that would be great. So that's on March 24th, and you could find that out at mathigon.org/PD is the way to sign up. All right. Great. Thank you, everybody. It was wonderful spending this time with you. I enjoyed it all and seeing some good stuff in the chat. So hopefully you found some value here and things that you can use in your classroom to engage your students in mathematics. Great. Thanks for coming, everyone. Have a great night. Go do some wonderful math. Look forward to hearing what you do with Mathigon.